Hey everybody, welcome back to another edition of the Cloud Native Short Takes. And today we're going to take a look at services. The RxM Services module covers exploring the nature of Kubernetes services and helps us understand the difference between cluster IP, node port, and load balancer service types. And then digs under the covers a little bit to make sure that we can choose the right service for the right task and debug them and effectively understand how they wire into the Kubernetes DNS system and all that sort of good stuff. So we've got a service called TestWeb. It has a cluster IP. And as we can see, it's going to allow traffic coming in on port 80 to go out to the backend pods that match the service selector. Now let's actually see if there are any backend pods that match the service selector. And this shows us our selector. We can see that these guys sync up, right? So our TestWeb service should match up with our labels. Now, I'm going to show how you can scale this service. Now, if I'd had a deployment, I could have just said scale, replicas 10 or something like that. But I'm going to do something a little bit more tricky. I'm going to do a kubectl, and I'm going to run another web type guy, but this time I'm going to use an Apache web server. And I'm going to call this web2. So let's go ahead and take a look at this guy. Now, if I do a kubectl get endpoints, this is a tricky way to see what endpoints your services have discovered. And so you can see that my service has only found one pod. And the reason for this is that my pod is that I just created is not having a run web label, right? It has a run web2 label. And so let's go ahead and take a look at the pods that we've got here, right? You can see this guy's, of course, he was called web2, so that's the label he gets. We can add labels to pods too, though. So I'm going to kubectl label the pod web2 with the label run web. Oops, I tried to change the label that already exists. You're normally not allowed to do that unless you use the overwrite flag like so. All right, now let's go back and look at our pods and look at their labels. And you can see that now the run key has been set to web for both of these guys. And if we then go and take a look at the endpoints, you can see that voila, without any extra work, the service has automatically picked up that second pod. And if we curl the service IP, you can see that this time we got the Apache web server. This time we got the Nginx web server, and so on. So the service not only gives you the ability to provide a stable network identity for all of these pods, but the pods can actually be incongruent, right? You could do a blue-green style deployment like I've just done. You could have your Python code running under Nginx and your Python code running under Apache. And as long as the API is the same, the client doesn't care which web server is, providing the interface. And this gives you the ability to have diversity and all sorts of other interesting things in your application. So the abstraction of a service is really a superpower in Kubernetes and gives us a lot of flexibility and a lot of control. This has been a look at the Kubernetes Services module. And so this is one of the many modules available in the custom courseware builder where you can tailor and design your own specific classes for you or your teams that meet the exact needs of the folks that are interested in learning more about Kubernetes. So, all right, take care, everybody, and we'll see you next time on a future Cloud Native Short Take.